Hello everyone. Today we will be doing quantum chemistry. So today the way I have made the video or the slide is actually a bit different because this included lot of calculations and equations as well, so which I was not able to type. So I just asked ChatGPT to type them for me. I wrote in the box over there in ChatGPT like what the equation is, and it helped me modify and write them. And I just snapshot took the snapshot and screenshot, sorry, and pasted it on Google Documents. So that's how today I made the content. I have 30 minutes. I'm using this software Clipchamp to record the video. So let's move fast. So quantum in today's topic we will be doing the calculation of the wave functions for different orbitals of hydrogen and hydrogen like atoms, like 1s, 2s, 2p, 3s, 3p, 3d, and so on. Okay, so let's move on to the next slide. So we all know that I'm like assuming that those who are watching this video know the basics of the quantum chemistry, and obviously that's why they are watching. But even if you don't, you can learn these formulas firstly. So when we talk about a wave function, I'll try my best to teach from the basics. Okay, whenever we talk about a wave function, we talk about a radial part, that is this r part, and this angular part that depends upon theta and phi, while the radial part depends on the r vector. These are the things when we talk about the spherical coordinates. There will be another video on the derivation um, of these spherical coordinates, and on the derivation of the Schrodinger wave equations, etc. But for now we are doing something else. So I'm assuming that we know that the wave function depends upon the radial part and the angular part. Now radial part can be calculated by this formula, that is r to the power l e to the power minus zr upon na, and this summation starting from j is equals to 0 to n minus l minus 1, and bj rj, where your this bj is a constant, and this n is your n and l. Everyone knows that l is your azimuthal quantum number, and now how can this bj be calculated? This bj can be calculated by this formula: bj plus 1 is equals to 2z upon na, j plus l plus 1 minus n, divided by j plus 1 and j plus 2l plus 2 bj. And so okay, so uh, this formula and this formula will help us to calculate the radial part. What about the angular part? So angular part, okay, so the radial part depends on n and l, while the angular part depends on l and m. Okay, so the angular part can be calculated by slm and your 1 by root 2 by eim phi. Okay, these are the things you need to learn. Now the thing is that these SLM are called legendary function, and these are well defined in mathematics. These are the values for different values of L and different values of M. Okay, so for example, you have your R1 0, like 1s के लिए, your 1s के लिए n will be 1, l will be 0. So you can simply put the value of l here, value of n here, n और l का वैल्यू यहाँ पे पुट कीजिए, उसके हिसाब से आप j इक्वल्स टू 0 और यहाँ पे जो वैल्यू आएगी उस हिसाब से आपका ये समेशन कीजिए, एंड यू विल गेट द वैल्यूज. आई हैव शोन two examples also. Okay, so for different values of l and m, the legendary function values are given. Okay, one more thing, that these functions are quantized, sorry, not quantized but normalized. So we need not to normalize them again and again. Okay, they can directly be multiplied with the radial part here. in order to form the wave function. Okay, so for example L equals to 0, m का वैल्यू भी 0 ही होगा, तो s00 के लिए this is the value of s00. Now in case of L is equals to 1, m can be 0, it can be plus minus 1, right? We know that value of m is from minus L to L, राइट. सो s10 के लिए ये वैल्यू होगा एंड s1 प्लस माइनस 1 के लिए ये वैल्यू होगा. सो this page you need either to learn, I will not say learn, but you can take the help of this page or theory for further calculations. Okay, so let's move on to the next slide now. Okay, now we are calculating for 1s, n equals to 1, l equals to 0. We will calculate, put the value of n here and l here, n1 0. R की पावर में l था तो r की पावर 0, e minus z r upon n a. N was 1, तो I'm just writing a here. Now summation j is equals to 0, n minus l minus 1. N is 1, l is 0, and then minus 1. So 1 minus 1 is 0. Now j is starting from 0 and ending at 0, यानी कि one term, that is b0 and r to the power 0. Okay, now r to the power 0 will be equal to 1. Here also r to the power 0 will be equal to 1, and b0 will have some value. Okay, it is a constant, and e minus zr upon a. Okay, so this is how the things happened here. Now when we got this radial part, we actually need to calculate the value of v naught. Okay, now how can this be done? This can be done by you know, knowing that any wave function is normalized. That is a theorem, and it is a fundamental, you know, like ये एक है, मतलब ज़रूरी है that wave function should be normalized. So and the condition of normalization I have given for the radial part is, this is we are talking about the radial part only, because the angular part I told depends on this SLM and these legendary functions are already normalized. So हम इससे मल्टीप्लाई करेंगे बाद में तो उसका कोई इफेक्ट पड़ेगा नहीं, तो हमें रेडियल पार्ट को भी नॉर्मलाइज बनाना पड़ेगा. एंड हाउ विल दिस बी पॉसिबल? Look, these are the ways, not ways, but uh, the methods or the normalization of different parts of a wave function takes place. The radial part is normalized by this method, the radial equation का whole square multiply by r square dr equals to 1 starting from 0 to infinity. The theta part, जो भी आपका ये फंक्शन होगा s का उसका स्क्वायर sin theta d theta equals to 1, एंड टी स्क्वायर डी फाइव ये आपका फाइव के ऊपर डिपेंड करता है. एंड दैट्स हाउ दिस इज नॉर्मलाइज. सो रेडियल पार्ट का भी नॉर्मलाइजेशन कर रहे हैं, सो वी विल यूज दिस फॉर्मूला. सो r10 का होल स्क्वायर r square dr equals to 1 0 to infinity. Now r10 we calculated at this, so if we put this here तो b naught square हो जाएगा, that came out because since it is a constant it comes out of the integral, and this r square comes here and this part was remaining and इसका square जो होगा वो 2 ऊपर चला जाएगा, so e minus 2 zr upon a and dr, and this is the value that we got. Okay, now how we got this value I have explained this. Look, uh, this is the formula that you have to learn for integration of anything like this. If you have in an integral that is from 0 to infinity, okay, so limits should also be the same. Okay, ऐसा नहीं कि 0 से 10 तक है, no. If it is from 0 to infinity and you have the integral of the form r to the power n and e to the power minus br in dr is equals to n factorial upon bn plus 1, right? So your n factorial, यहाँ पे r का n था यानी कि 2 पार थी, तो 2 का factorial is 2, right? 2 का factorial is 2, and e minus br, if we compare with it with this e minus 2z upon ar, तो माइनस भी है r भी है b is equals to 2z upon a, तो b नीचे आ जाएगा 2z upon a and n plus 1, 2 plus 1 is equals to 3, so on calculation this will become a cube upon 4z cube. So this integral part comes out to be a cube upon 4z cube, which is again multiplied by b naught square. But what happened that we have normalized this thing. Now the normalization के बाद ये 1 के equal होना चाहिए था. So we can calculate this constant now. So b naught is equals to 2z 3 by 2 upon a 3 by 2, a का part 3 by 2. So we got the b naught and we can substitute this b naught here, and thus we got the radial part. R10 is equals to your b naught का value and e की power minus zr upon a. So you got the radial part, right? अब हमें देखना है angular part. तो y00 is equals to s00. ओके, सो एंगुलर पार्ट का फॉर्मूला क्या था, हमने यहाँ पे देखा था एस एल एम वन बाई रूट टू पाई ई आई एम फाई. नाउ फॉर 10, right, for 1s your n equals to 1, l is equals to 0, so your m will also be equals to 0, right? So s l is 0, m is 0, so s00 is 1 by 2 root 2. Now look, we have 1 by 2 मल्टीप्लाई बाई रूट टू, यानी रूट टू बाई टू हमारे पास ऑलरेडी है. 1 बाई रूट टू पाई भी आ गया, एस जीरो जीरो वॉज 1 बाई टू रूट टू, ये आ गया 1 बाई रूट टू पाई आ गया. एंड ई आई जीरो फाइव, एम का वैल्यू जीरो हो गया, तो दिस होल टर्म विल बी जीरो एंड ई टू द पावर जीरो इज़ 1. सो इसको कैलकुलेट करके हमारे पास आ जाएगा 1 बाई रूट फोर पाई. एंड यू नो दैट वेव फंक्शन इज रेडियल पार्ट मल्टीप्लाइड बाय angular part. So radial part was this thing 2z by a 3 by 2 a minus zr by a, and this thing, and on further calculation that this 2 comes out, right? Root 4 is 2, right? So 2 से 2 कटा and 1 by root pi रह गया, z by a 3 by 2 a minus zr by a. Now इतना तो हो गया. Now you know that we in the calculation of 1s, what we did is we calculated b0, right? Now by keeping in mind the value of b0, you can calculate anything, okay, from this formula, this bj plus 1. For example, you have to calculate b1, it will be b0 plus 1. Okay, so b0 plus 1, so you can put j, then you can get b1. In case you have to calculate b2, you have to calculate b1 first, because b1 plus 1 will be b2. So you can put the value b1 here, और यहाँ से b2 का वैल्यू आ जाएगा, यहाँ पे j का रिस्पेक्टिवली वैल्यू पुट कर लीजिएगा फॉर कैलकुलेशन फर्दर. ओके, सो इतना आई होप आप लोगों को समझ आ गया होगा. नाउ लेट्स मूव ऑन टू द 2s. Your n is equals to 2 and your l equals to 0. So r2 0, r की पावर अगेन 0, r टू द पावर l होता है, एंड e माइनस जेड आर अपॉन एन ए रहता है, तो n इज टू समेशन j इज इक्वल्स टू 0 टू n माइनस l माइनस 1, n is 2, l is 0 1, so bj rj. So this r0, r to the power 0 becomes 1, and this comes out to be e minus zr upon 2a, and 0 to 2 minus 1, 0 to 1. So 1, once you have to put b0 r to the power 0 plus b1 r to the power 1. तो b1 r, b0 r to the power 0 is 1 again, so ये तो b0 आ जाएगा. Now you know that we know the value of b0, right? But we need to calculate b1. How will you do that? b1 is equals to b0 plus 1. Now this is your j, like bj plus 1 is equals to, like from this formula, um, bj plus 1 is equals to this formula and bj. So in case you have to calculate b1, so to make this term 1, you have to put j is equals to 0. So b0 यहाँ पे, अब j का वैल्यू 0, l पता है, n पता है, we can calculate b1. Okay, so where were we? Okay, so b0 plus 1, so 2z upon 2a, this is j plus l plus 1 minus n. 0 plus l is again 0, and 1 minus n is 2. This is j plus 1, 0 plus 1. j plus 2, l plus 2. So l is 0, j is 0, so 2l also will be 0, तो ये plus 2 आ गया. And this 2 into z upon a whole 3 by 2 is our b naught. So by calculations, we got this thing 2z minus 1 upon 2a, 1 2 into 2 into this is your b0, this is your 2z upon 2a जो हमारा था ही, और ये हमारा j प्लस एल प्लस 1 माइनस एन का वैल्यू है, ये हमारा j प्लस एल का वैल्यू है, और ये हमारा है वैल्यू किस चीज़ का, j प्लस 2l प्लस 2 का. Okay, so on solving this thing, we got माइनस का साइन ये वाला, टू से टू कट गया, ये टू से ये वाला टू कट गया, जेड अपॉन ए पार वन, जेड अपॉन ए पार थ्री बाई टू, तो पार पार प्लस हो जाएंगे बिकॉज इनके जो आई वाज से जो जिनकी ये पार हैं दे आर सेम, so 3 by 2 plus 1 is equals to 5 by 2, so minus z by a 5 by 2. Now put b1 here, b naught का वैल्यू you know that and r is already there, so radial part आपका कैलकुलेट हो जाएगा, तो e माइनस जेड आर अपॉन टू है, बी नॉट माइनस आर, बी नॉट का वैल्यू होता है, लुक ये एज इट इज़ आ गया, ये चीज़ एज इट इज़ आ गई यहाँ पे, पी ज़ीरो का वैल्यू पुट कर दिया जो हमने कैलकुलेट किया था, टू इंटू जेड बाई ए की पावर थ्री बाई टू माइनस आर यहाँ पे आ गया, और बी वन का वैल्यू हमने कैलकुलेट किया है दिस थिंग, सो यहाँ पे प्लस का बी वन था बट बी वन का वैल्यू नेगेटिव है, नेगेटिव ऑफ जेड बाई ए फाइव बाई टू, तो ये चीज़ यहाँ पे आ गई। अब यहाँ से हमने क्या किया, जेड बाई ए थ्री बाई टू को कॉमन ले लिया, और ई माइनस जेड आर अपॉन टू ए तो था ही, तो यहाँ पे अंदर रह जाएगा टू माइनस जेड आर बाय ए, क्योंकि एक जेड बाय ए बच जाएगा यहाँ पे जब आप कॉमन लोगे, एंड आफ्टर दैट व्हाट हैपेंस दैट वी टेक टू को ऑल्सो कॉमन, तो दिस विल रिमेन वन माइनस जेड आर अपॉन टू ए। बट अब ये रेडियल पार्ट आ तो गया, बट this is not normalized, and we know that wave functions are normalized, so we have to normalize it again. Now in order to normalize it, what we do is we multiply it with a constant n and proceed for the normalization condition, and normalization condition kya thi, this condition, we apply this condition again and we multiply it with n. Okay, so n is, what is n? N is a constant which when multiply with the radial function will make it normalized. Okay, so we multiplied it, we used this condition with n, and r का स्क्वायर, आर स्क्वायर ये वाला तो आ ही गया यहाँ पे, और इस पूरा इक्वेशन का स्क्वायर, एंड डी आर इक्वल्स टू वन। सो नाउ सबसे पहले हमने क्या करा, वी टुक दिस पार्ट एंड वी एक्सपेंडेड द स्क्वायर, तो एन स्क्वायर, ओके, ई माइनस जेड आर अपॉन टू ए, इसका स्क्वायर यहाँ पे टू आ जाएगा, और टू से टू कटा तो ई माइनस जेड आर अपॉन ए आ जाएगा, फाइन। देन हमारे पास ये आर स्क्वायर भी यहाँ पे आ गया, राइट, and this 2 will form 4, and this z by a will be cube, and 1 minus z r by 2a का square. So this is the thing. Now we have to open this term, तो ये इस तरीके से open हो जाएगी, put these things here, so this integral will become like this. Okay, now what we will do is that we will take the constants out, this n square, this 4, and this z by a ka whole cube is also taken out, because this r square is e minus z r upon a, and these terms are the only ones that depend upon r. Okay, so we take out n square z by a ka whole cube and this 4. Now we expand this term like this, r square e minus z r upon a dr minus z by a, and integration इनका again very easy. We take it as I, and I eventually is equals to 1. We all know that, right? Now you can take these things out and separately find their integral from the formula that we used in the case of 1s, that anything integration from 0 to infinity rn to the power r to the power n e की power minus br, and dr is equals to n factorial by b की power n plus 1. So when you do this for this first term here, right, so this is again 2a cube by z cube. When you do this for this term, you get 6a4 by z4, and when you do that same formula for this term, the third one, you get this. Now you put these value here in this equation, so you will get I is equals to n square z by a ka whole cube 4, and 2a cube by z cube minus, look, z by a was already here, and the integral came out to be 6a4 by z4, and similarly this thing. Now what you can see that this z will cancel out 1z from here, this a will cancel out 1a from here, this will cancel out 2 from here, 2 z's from here, and this will cancel out 2 a's from here, right, and this 4 will give 6. 24 by 4 is equals to 6, right? So what happens that we see that in each one of these terms, we get a cube by z cube, and outside of the box, we have z by a ka whole cube. So eventually, these z by a and a by z terms are getting cancelled out. So you can see, as I have shown here, this will be the final expression that we will get. Now I'm just again doing what that okay, so what I have done here is that I have solved this thing, so these two things will cancel out and this will eventually give this. Okay, so we have this. Now we substitute it here. So I is equal to n square z by a ka whole cube 4 to a cube by z cube. These things will cancel out and this will give me 4 2s are 8, 8n square is equals to I, and I was equals to 1. 8n square is equals to 1, n square is equals to 1 by 8, n is equals to 1 by root 8, and which this is equals to 1 by 2 root 2. Now r20, the radial factor r20, हमने बोला था that it is n multiplied by that radial part that we calculated, right? So 1 by root 8, and this is the radial part that we calculated. And what I do now is just put this 2 inside the root, that will become root 4 by 8. 4 से 8 कटेगा तो 1 by 2 आ जाएगा, तो root 2 नीचे बच गया, and this is the term that I get for the radial part, right? 1 by root 8 and 2, we simplify them and this will turn out to 1 by root 2, and this is the radial part for r20. Again we calculate that we know that the wave function is the radial part and the angular part, and angular part for 0 0, as in the case of 1s was 1 by root 4 pi. Okay, so what we do is now we multiply both the radial part and the angular part, and we get an equation that is 1 by root 8 pi and this thing. Now 1 by root pi and 1 by root 8 is actually separated. So, and because now root 8 is 2 to the power 3 by 2, I have 2 to the power 3 by 2 in the denominator, root pi in this term. Now you see there are two terms that have the power of 3 by 2, this term and this term. So 2 can go inside this bracket. So I'm doing that. I'm taking 2 here, z by 2a 3 by 2. This term remains like this, 1 minus zr by 2a and 1 by root pi. So in this manner we can calculate the wave functions for 2p, 3s and so on. Okay, so these are the radial parts for different orbitals. You can try them, you can calculate them if you want to. Okay, and I have also attached a table from ChatGPT that consists of wave functions of different sorry, wait a minute, that consists of radial part and angular part for different cases of n, l and m. Hoping that you understood what I wanted to convey, and thank you. Okay, so in case you want to refer some book for quantum chemistry, I would suggest you to go for Ira and Levine. Book is really good for quantum chemistry basics, and I have also referred for this content from that book only, and it's a very good book. You should give a read, and all the best for studying this topic and other topics of quantum chemistry. I will be sharing soon some other videos as well related to quantum chemistry. It's really interesting topic and this was a very good part of it. Actually, I'm studying this topic right now and I like this part very much, and because it took a lot of calculations and I'm good at mathematics also, so I just like this topic, so I thought why not make a video. Actually, I started making a video earlier on wave function, and I was typing all the things on that Google presentation, but it was very hectic for me. But since now I have found another way of like telling ChatGPT to write the equations and all, now I will be making the presentations in this form only, I guess, for at least for quantum chemistry because a lot of equations are there. So let's meet in another video. I don't know, maybe I think I will be doing it for time dependent and time independent Schrodinger wave equation. So let's see when the next video comes. I hope it comes soon. Okay, and happy new year to the ones who are watching it. Thank you. All the best.